Combustion is a type of reaction between oxygen and a fuel that releases energy in the form of heat and light. What's important about a combustion reaction is that it always involves oxygen. Now the fuel can be all sorts of different types. It could be a fossil fuel, it could be sugar within the body in cellular respiration, it could be the combustion of a metal. But importantly, oxygen is always involved. And it releases energy, so that means it's an exothermic reaction. So let's go through and look at some specific examples of combustion reactions. The first one is what we call complete combustion. So that's the complete combustion of a fossil fuel. So let's do an example with methane, CH4. That's the gas that comes out of the Bunsen burner. Now it's a reaction with oxygen, so the other reactant is oxygen. Complete combustion has two products, carbon dioxide and water. Now we need to balance that. We've got one carbon on each side, that's fine. We've got two oxygen on this side, and we've actually got three oxygen on this side. So if we put a 2 here, then we've got 4 oxygen. 2 times 2 is 4 oxygen. So now all we need to do is, well, that's it, we're done. Because we've got 4 hydrogen, and 2 times 2 is 4 hydrogen. Okay, so this is methane, this is oxygen, this is carbon dioxide, and water. That's complete combustion. What's really important for a combustion reaction is that sufficient oxygen is present. If there's not enough oxygen present, we have incomplete combustion. We're going to use the same fuel, methane, and we still say O2. Even though there's not enough oxygen present, it's still obviously in the form of O2. So when there's not enough oxygen present, instead of producing carbon dioxide, what's produced instead is carbon monoxide. So carbon monoxide is a very dangerous gas because carbon monoxide, when it's breathed in, it actually binds to the hemoglobin in the blood and stops oxygen from being able to bind. So if somebody who's exposed to carbon monoxide and is poisoned by carbon monoxide gets very sick and can often die because the body can't transport oxygen to the cells. So carbon monoxide is produced, and also water. Incomplete combustion is actually a pretty tricky one to balance. Let's go ahead and see if we can do it, but bear with me, and this is a hard one. Alright, so I'm going to start with a pencil because I'm going to have to change the coefficient as I go. Alright, where are we going to start? Okay, 4 hydrogen, 2 hydrogen. So let's put a 2 here. So that means 2, so it's 4 hydrogen, 4 hydrogen. But now we've got 3 oxygen. So 2, so we need to put a 2 here. So now we've got 4 oxygen, put a 2 here, 4 oxygen. Now how's it looking? We've got 2 carbon, so we have to put a 2 here for 2 carbon. So now we have a problem with our hydrogen. 2 times 4 is 8, so I need to put a 4 here. So we've got it's 8 hydrogen, 8 hydrogen. Now we've got a problem with our oxygen. We've got 4 oxygen plus 2 oxygen, so that's 6 oxygen. Put a 3 here. Now that's balanced. So there was a bit of work there. Sometimes it's a trial and error. So that was a 4, that was a 2, that was a 3, and that was a 2. Goodness. Now, that's not even telling the whole story with incomplete combustion. There's actually another reaction that occurs at the same time. Because I'm sure you know that when a fuel is burnt, sometimes smoke is produced. Again, that occurs when there's not enough oxygen. So methane plus oxygen produces another chemical reaction where we've got carbon, which is the soot, and water vapor again. So let's go ahead and see if we can balance that one. Okay. So again, we've got 4 hydrogen, so we need to put a 2 here. So that gives us 2 oxygen, 1 carbon. So that's balanced. So there's actually 2 reactions that occur with incomplete combustion. Incomplete combustion means there's not enough oxygen to burn. So both of these occur in a Bunsen burner. So when we have the working flame, when there's plenty of oxygen, the hole is open at the bottom, then we just produce carbon dioxide and water. You've got that hot blue flame. But incomplete combustion occurs when the sleeve is closed and the hole is not exposed. There's not enough oxygen going through. So carbon monoxide is produced as well as carbon. The combustion of a metal, if for example we have got magnesium ribbon and that is burnt in a flame, so we put it under that Bunsen burner first of all to get it started, and then it's a very bright, very, very strong, bright light reaction occurring, so it's exothermic. What we're left with is magnesium oxide. Now, so that is the formula for magnesium oxide. So we've got 1 oxygen here, 2 oxygen here, and that's balanced. So the combustion of a metal produces an oxide. So this is the magnesium metal, oxygen, magnesium oxide. Okay, so that's combustion of a metal. Finally, I want to show you, here's another type of combustion reaction. Now this occurs within an organism, within the cells of an organism. This is the burning or the combustion of glucose, C6H12O6, in the presence of oxygen. In our cells, in the mitochondria of the cell, glucose is burned. It's the combustion of glucose in the presence of oxygen to produce the same 2 products of complete combustion, CO2 plus H2O. This is the carbon dioxide that we breathe out. This is the oxygen that we breathe in. Now, of course, the other thing that gets produced is energy. A large amount of energy that's used for all of our processes in the body. Now, this isn't actually balanced. It's a tricky one to balance, but it's easy to remember because that's balanced there now. So this is a great one because clearly we know that in our body, combustion occurs in a very, very controlled process. We don't have spontaneously bursting into flame, even though I've got all this fuel that we're burning. So combustion actually can be very well controlled with small series of reactions. But ultimately, this is the process, is releasing a lot of energy by burning fuel in oxygen, and complete combustion involves production of carbon dioxide and water plus energy.